Pre-calculus Math 1415, Final Exam Review, Part 1. In questions 1 through 7, you're going to use this figure to answer these questions. They want to know what the domain are all your x values. So if you look at your picture here, and you always start from the smallest. So the smallest x value is -3, and it's including it because you have a closed circle here. And it's going straight through all the way to 4. So, and it's including 4. So from -3 to 4, and we're going to use brackets, not parentheses. If these had been open circles, you would use parentheses around -3 and 4. And your range is your y values. The smallest y value is -2, and it's including it. And it goes all the way up to 4, and including 4. So the correct answer is A. Number 2 is a composition of functions. It's an f of f, so you're going to plug 2, it's going to be your domain. 2 goes in the f function, so that's your x value. So if you plug 2 into this function, that's your f function. If you plug 2 in, what comes out is a 0. And then you're going to plug 0 back into this, and if you plug 0 for x, you get 4. So 4 is the correct answer. Okay? This next one is asking you the interval where it's increasing. You always read a graph left to right. So as you're coming from the left and approaching this picture, this graph, the x values are increasing from this value, you're going all the way up to this. So from here to here, from -3 to 0, you're increasing. And you're also increasing from this 2 to this 4. So from 2 to 4. We use parentheses to show that at the top, you're not increasing or decreasing. So from -3 to 0, our graph is going up, and from 2 to 4, it's also going up. So E is the correct answer. Okay, now, it says the absolute minimum value, the smallest value of y is -2. We have a local maximum of 4. So we want the f, like the y value of that. How many distinct zeros do we have? So we want to count the x-intercepts. We have 2 of them. We have 2 x-intercepts. So there are 2 distinct zeros. That would be C. And does this function have an inverse? That's a function? No, it does not, because it does not pass the horizontal line test. The horizontal line test clearly shows here that this is not 1-to-1. So that predicts that the inverse will not be a function. So that's a no. Okay? Now, number 8. How do you determine what would not be a function? Well, what you're going to do is either solve your equation for y, and if the y value is odd, if it's an odd power, you're not going to have plus or minus. But in this case right here, C is not a function, because if we solve this for y, you would end up with y squared equals -3x squared plus 9. And when you take the square root of 9, you end up with plus or minus. So it's not unique, and you have 2 values, and it's not going to be a function. And plus it's a circle. If you recognize, we did plenty of these in class. This graph is a circle, and a circle does not pass the vertical line test, therefore it's not a function. This is fine, and this is fine, and all these x values are not repeating, so that's fine. So C is not a function. Okay? Next one. How do you find all the intercepts? They're talking x and y intercepts. So they're asking you to plug in 0 for x and for y. Those Those are your x and y intercepts. So if we plugged a 0 in here for y, what two values would you get? You get -5 and also +5. And if you plugged a 0 in for x, you get 25. So what are your intercepts? It would be B. Number 10. How do you know if something is symmetrical with respect to the x-axis, the y-axis, or the origin? Well, this one, to see if it's symmetrical to the y-axis, you replace x for -x. So if I were to put a -x here and solve it, I get the same equation. You get the same thing. To see if it's symmetrical to the x-axis, you plug a -y in here. So x squared plus 7 equals -y. And because they're even powers, it's a yes. In the origin, you replace both x and y. And if you get the same thing, so -x squared plus 7 equals -y squared, and you get the same problem. So this one has symmetry to all three of them. Okay, number 10, or 11, sorry. This one, if we were to replace y for -y, we will not be able to get this back to its original. Same with if we replaced x, we have two x's here. This one would be fine, but this is not going to help. So, but because if I do both x and y, if I do this, what I'm going to get is if I multiply both these sides left and right, this one's going to go back to x squared no matter what. But I would have to multiply both sides by -1, which is fair game. So you'd end up back with the original problem. So this one has symmetry to only the origin. Only the origin. Number 12. When you have a square root where our domain is not all real numbers, because you don't, a square root, any kind of index that's even, 2, 4, 6, 8, you can't take the square root of a negative number. So what you do is you set what's underneath it, which is x plus a. You want this to be greater than or equal to 0. That means positive. So set, no matter what, set what's underneath only if the index is even. If it were odd, if this were a cube root or a fifth root, it would be all reals. But because it's a square root, this, what's underneath the radicand, can't be a negative number. So you set it equal to greater than or equal to 0. That's what you want x to be. So you would subtract a, so x would be greater than or equal to -a. So C is the correct answer. Number 13. I want you to find x plus 2. So this goes in place of x. So you're going to square x plus 2 squared, and then subtract 2. Well, you have to FOIL x plus 2. You get x squared plus 4x plus 4, and then minus 2. 4 minus 2 is 2, so B is the correct answer. Okay. Number 14 is the difference quotient rule. So this is a little bit more lengthy. You have to evaluate this function for x plus h. So if we plug x plus h right in here, you have 6 times x plus h plus 2. That's what x plus h is. Then you're going to subtract. If you plug an x in here, you're going to subtract 6x plus 2. And you're going to divide everything by h. So you end up with, distribute the 6x plus 6h plus 2. This, now you're not distributing that 2, it's just plus 2, minus 6x minus 2, all over h. Now what cancels here are 6x minus 6x cancels, 2 minus 2 cancels, and you have 6h over h, the h's cancel, and you end up with just plain old 6. Next one, 15. This one's a little bit more involved. You still have to do x plus h. You have to plug x plus h here and here. So it's x plus h quantity squared minus 4 times x plus h and then plus 1. All of this is f of x plus h. We're going to subtract f of x. We're going to plug x into this whole thing. So x squared minus 4x plus 1. And then we're going to divide the whole thing by h. So we need to simplify. Squaring x plus h, we get x squared plus 2xh plus h squared minus 4x minus 4h and then plus 1, then minus x squared plus 4x and then minus 1 all over h. So let's see what cancels. The x squareds are gone. I see 4x here, negative 4x, those are gone. I have a 1 and a negative 1 that's gone. Now here I end up with 2xh plus h squared minus 4h over h. I see a common h in all three spots. So if I pulled out an h, if I factor an h out, and I will show you that. So what's left is 2xh plus h squared minus 4h all over h. You should see an h common. Take the h out. You're left with 2x plus h minus 4 all over h, which these h's cancel. So the final answer is 2x plus h minus 4, which is e. Okay? This next function says y equals x to the fourth power, x to the fourth minus 5x squared. Now, if you want to see if it has symmetry to the y-axis means even, origin means odd. Okay? So, you have to know what these terms mean. But if you were to replace x for negative x, because both of these x values have even powers, you will get this back to its original. So you would have y equals x to the fourth minus 5x squared. So because if you replace x for negative x, that means it has symmetry to the y-axis, which means it's an even function. Odd means if I place both x and y, in this case it would not work. But neither means it's not even or odd. So A is the correct answer. Number 17. Whatever function you have, whatever you have in grouping symbols, will shift your graph the opposite left and right. So this is a shift 3 units to the left. 3 units to the left. And we can run through these really quick. The number in front, let's say I put a 5 here, that would be a vertical stretch by 5. If it was less than 1, it would be a vertical compression. Then we have your function. This is going to shift your graph opposite left and right. And then you're going to have, I'm going to put parentheses around that. And if you have something outside here, this is going to shift your graph up or down. Now, if there's a number inside here, that's a horizontal stretch or compression. You'd have to flip that number, and if it's less than 1, it's a horizontal compression. If you flip it and it's greater than 1, it's a horizontal stretch. So, but 17 is D, 3 units to the left. Okay, here's another example, 18. If I go from f of x, y equals f of x to f of x minus 3, that's a shift 3 units down. And this one's a reflection over the x-axis, that's what the negative does. 3 units to the left and down 2. It's a combination of all three, so A. Number 20, use transformations to identify the graph. This one, if you looked at this, you could just actually do this one by slope-intercept form. This is going to hit the y-axis at 2, and it has a negative slope. It's going down 2, so it's A. 21, if you were to set this equal to 0, because they are asking you for the zeros. If you set this equal to 0, and solve this, you'll find your two answers, your zeros. So how do you solve this? I'm going to write this the other way. Sometimes it's easier to handle this problem that way. So the first thing you want to do is get rid of this 5. Subtract 5. Then you want to get rid of this negative 2. Divide by negative 2. Please do not distribute that. So you have x minus 3, absolute value of that, is equal to, I'm going to write this as 2.5. 5 halves is 2.5. Now, when you get your absolute value by itself, you're going to break this up into two problems. X minus 3 equals 2.5, and x minus 3 equals negative 2.5. Solve both of these. If you add 3, x is 0.5, and add 3, 5.5. So they want you, in this question, these are the two x-intercepts. They want you to add these two x-intercepts together. Well, what's 5.5 plus 0.5? The answer would be 6. Okay? Now, if you were to graph this, okay, this is, your vertex is over 3 and up 5. So over 3, x is the opposite of that, and up 5. So it looks something like this. Okay, so why do I know it's upside down? Because of the negative 2. So this ordered pair at 3, 5, that is your maximum value. So what is the maximum value? It is 5. That's your maximum value of f. Okay, the range of this, okay, so this is the range. It's going from negative infinity all the way to 5, and including that. So y is less than or equal to 5. Now, if they write it in interval notation, it would look like this: negative infinity, comma 5 with a bracket, just in case. Always start with your smaller number, go to your bigger. So had this absolute value function been going the other way, and this was 5, it would be from 5 to positive infinity. So that would be your range. By the way, your domain is all real numbers for absolute values. So the range is from negative infinity to 5, or y is less than or equal to 5. Now, what interval is this decreasing? It's decreasing from 3 to infinity. So if you looked at your picture here, the x, we always talk about increasing and decreasing from our x values. So 3 is our x value. It's decreasing from 3 to positive infinity. 25. You should, we had a question like this on our test. So, y equals x. That's a line. That would be B. X squared. That's a parabola. A. x cubed, that's the cubic function, h. Absolute value, we just did it, d, it's a v. Square root, looks like a rocket, e. Cube root, looks like a snake, f. The reciprocal function is c. And what's left? G. Okay. 26. I'm asking you to plug 3 in. This is a piecewise function. But I only want to use 3 into which of these? I'd have to use the bottom one, because the domain for this one is from 3 to infinity. But this one is 3 less than 3. So I'm not going to plug 3 into the top one because 3 is not in the domain. So it's 3 squared, which is 9. Same with 27. Negative 2 has to go into the top one. 2 times negative 2 is negative 4 minus 1 is negative 5. Now this one, 28, the intercepts. If you find the x-intercepts, you're going to plug 0 in for y. Well, if I plug 0 in for y, 0 is equal to 2x minus 1. If I solve this for 0, I would be adding 1 and dividing by 2. So I can only find the x-intercept for this one because this one, I'm not plugging x's, 0 is not part of the domain. It's only for x values that are greater than or equal to 3. So I can find the x-intercept for this, but not this, because this is only for x values greater than or equal to 3. So the only x-intercept is B. 29, how do you find the maximum value? Maximum value, this is a parabola, and it's upside down, so it'll be shaped like that. So your maximum value is your vertex. So how do you find your vertex? It's the formula, negative b over 2 times a. Well, that's your b value, 6. So it's the opposite of 6, negative 6, divided by 2 times your a value, 2 times negative 3. So it's negative 6 over negative 6, which is 1. So at 1, you're going to plug 1 in for x. 1 squared times negative 3 plus 6 times 1 plus 7. Do your math, and 10 is your maximum value, and it occurs when x is 1. The maximum value is 10. Number 30, the axis of symmetry is that formula, x is equal to negative b over 2a. So the b value is 12, so it's negative 12 divided by 2 times 2. So it's negative 12 divided by 4, which is negative 3. That's your axis of symmetry. But the vertex is found by plugging that x value in here. So what is 2 times negative 3 squared plus 12 times negative 3 minus 5? Okay, do your math, and you should get negative 23. This is 18. 9 times 2 is 18. Minus 36 minus 5. This is negative 18 minus 5 is negative 23. So your vertex is negative 3, negative 23. So let's look at this picture. So if our vertex is negative 3, negative 23, which is negative 3, negative 23, let's pretend like it looks like this. Something like this. This is negative 23. What is our range? It's going to be from negative 23 up to infinity. So D would be your correct answer. Your domain, if they ask you, it's all real numbers. Number 33. So we have a projectile and it's being fired from the ground. They give you the formula, h equals negative 16t squared plus 320t plus 300. I want to know when, which is time. So when we graph this, this is time and this is height. So it's going to look something like this. I want to know when will it reach its maximum height? So I want to find this x value or t value. So I need to use x or t is negative b over 2a. And b is going to be 320, so it's negative 320 over 2 times negative 16. If you do the math, you get 10. So in 10 seconds, it will reach its maximum height. And in the next question, they want to know what is the maximum height. So you plug 10 in for this into this formula. So h is equal to negative 16 times 10 squared plus 320 times 10 plus 300. So what is that maximum height? This is 10 seconds. And when you do this math, you get negative 16 times 100 plus 3,200 plus 30. So you have negative 1,600 plus 3,200 plus 30, and you get, this is 1,600, I'm showing you all the steps, and you get this is 300, sorry, 300, right? 300, yep, forgot that 0. So this would be 1,900. So it reaches the highest at 1,900 feet. And I will continue. Part 2.